All right, hello once again. This is Jeff Scott continuing on with our PowerPoint presentations for the Murox MySQL second edition book for the 152-147 Relational Database Development class at Blackhawk Technical College for the spring 2016 semester. We're now into Chapter 14, which is how to use transactions and locking. And let me mention as we begin, this would not really have much usage for the way we set up things at Blackhawk. When you're talking about transactions and locking, then what you're doing is you're talking about a situation where if at Blackhawk we don't have this, but if at Blackhawk we was set up that we had one copy of MySQL server running on a database server and we were all sharing it, then transactions and locking would matter a lot more than it would in the way we have it, because we all have our own individual copies. All right, so just kind of keep that in mind as we get started. So we'll talk about working with transactions, how to begin one, commit one, roll one back, how they're used, what a save point is, what locking is, different transaction isolation levels, the topic of deadlock, and 3 techniques that can reduce deadlocks. Let me just say too that when we start talking about a transaction is a unit of work. So imagine that I went to the bank, and when I went to the bank, let's just say I go into the regular bank. I usually use the drive-through, but I don't even have to do that. So let's say I do that. I go into the bank and I'm depositing, let's say, 2 checks. Let's assume it was my birthday and I got a check from my parents for $50, and let's assume that I got a work check that was for $200. So I want to put $250 into my bank account. Okay? And then let's also suppose that I want to be able to write a check at the same time and drop it off at the bank. And that check that I'm going to write is for, let's say, my electric bill, and it's $75. But all these are related. They're all one transaction. I want to do 2 deposits and basically the equivalent of 1 withdrawal. Well, with a transaction like this, it's a unit of work that either everything succeeds or everything fails. So in other words, think about the problem that you could have if for some reason I was able to do the withdrawal, but my deposits didn't take. That kind of an idea. So here's a transaction. So we're starting a transaction in here, and we're inserting a record into a table. We're inserting a record into another table. We're inserting a second record into this table. Then we're saying, okay, if there weren't any errors, call commit. Well, commit, literally the way that commit works is by default, the way that MySQL works is the way that Access works, and that is once you're working on a record and you move off of the record, it automatically saves whatever it is you're working on. But when you're working with transactions like this, you typically turn the auto commit feature off, and you turn it off so that you can manually tell the system when to commit or not commit. So if the whole thing worked and everything looks copacetic and fine, as they say, commit and say that the transaction was committed. Otherwise, roll it back. Roll it back means make it look the way it did before we did anything. Okay? So it says, when should you use transactions? The idea, you can read this, and I'll leave this up here, but the idea is that whether they're directly or indirectly, when they're talking about doing something, 2 or more of this, 2 or more of that, it's something that is directly or indirectly related. So you could say, as an example, I mean, this just popped into my head, and maybe this will be a good example, maybe it won't be. But let's say that my wife tells me to go to the store. All right, she says, while you're at the store, what I want you to do is I want you to buy some dip, chip dip. We're having a party, and we've got everything, but I forgot. She says, I forgot chip dip. Then when you get done, I want you to go over to the dry cleaners and pick up her dress for the party. Then when I'm done with that, I'm supposed to go to the store and buy myself a pair of pants because my pants don't fit. So it's all that stuff is related, whether it's kind of tangentially related or directly related. All of it together would be in database ease, would be thought of as being a transaction. Now they put it more in database terms here. It says when you code two or more insert, update, or delete statements that would affect data that's related in some way. When you move rows from one table to another with inserts and deletes. Whenever there's a failure with an insert, an update, or a delete that would work on integrity. All right? Now, this is a little bit more harder to understand right here, this save points. Because when you roll back, you can set up save points. So notice here that I've set up 1, 2, 3 save points. All right? So now I can say, okay, if there's a problem, I can roll back to any of these points. So if I roll back to this point right here, what I'm saying is I want it to be as though nothing has ever happened. If I roll back to this point, then this insert worked, but the rest of them didn't. And if I roll back to this insert, to this save point, then this happened and this happened. All right? And then we've got another save point. All right? So the idea here with save points is you're kind of telling the system, okay, I want to back up, but I maybe don't want to back up to the beginning. Okay? You can have multiple save points, but let me just tell you that if you have a save point here and one there and you have too many of them, what's going to end up happening is one save point is going to end up clobbering another one. Again, this would be a good time, and I should have mentioned this before and didn't, but if we go back here to our reference manual, all right, you'll notice that if we do go back here and stored programs, for example, all right, there in triggers, that's the stuff that we would have been talking about, so there's more in there, but I'm sure somewhere in here, I don't know exactly where it is, but my guess is if I look in here long enough, in fact, let me just click right here. I'm going to try to type in transaction. All right, and they talk about transaction levels in here. All right, I have no idea if anywhere in here, if I try putting in the word save point, if it's going to find it. It looks like it's not. But if I search the manual for save point, it should find something. Save point, roll back to save point, etc. Notice there's 14 results. So if you want more than I'm giving you, and believe me, there's a heck of a lot more than what I am giving you, go to the reference manual and take a look. Okay? All right, different problems that you can have. Now, when they talk about concurrency problems, in English, what they're mentioning is, again, you've got more than one person who's trying to update the same record or the same table or the same database or the same something at the same time. All right, again, you're talking about a case in which you have multiple people sharing the same copy of the database. So they talk here about 4 different problems that you can run into with this concurrency, concurrent users. In other words, more than one user trying to use the same thing at the same time. The first is a lost update. And they mention in the book here that a lost update would occur when 2 transactions select the same row, in other words, the same record, and they update the same record based on the values originally selected. Each transaction is unaware of what the other one is doing. So the later transaction overwrites the earlier transaction. So whoever saves last wins is the type of idea there. Dirty read. A dirty read occurs when a transaction selects data that has not yet been committed by another transaction. They give an example here on the top of page 409. It says transaction A changes a row. Transaction B then selects the change row before transaction A committed the change. If transaction A then rolls back the change, transaction B selected data that doesn't exist in the database. Non-repeatable read occurs when two select statements that try to get the same data get different values because another transaction has updated the data in the time between the two statements. For example, transaction A selects a row. Transaction B then updates the row. When transaction A selects the same row again, the data is different than it had been previously. Finally, phantom reads. They occur when you perform an update or delete on a set of rows at the same time that another person is performing an update or delete that affects one or more rows in that same set of rows or records. For example, transaction A updates the payment total for each invoice that has a balance due, but transaction B inserts a new unpaid invoice while transaction A is still running. After transaction A finishes, there is still an invoice with a balance due. Now, the author mentions underneath this in the description on page 409, he says, in a large system with many users, you should expect these kinds of problems to occur. In general, you don't need to take any action except to anticipate that there could be a problem. In many cases, if the SQL statement is resubmitted, the problem goes away. On some systems, if two transactions overwrite each other, the validity of the database is compromised, and resubmitting one of the transactions won't eliminate the problems. If you're working on such a system, you must anticipate these types of concurrency problems and account for them in your code. All right. Finally, if one of these problems could affect the data integrity of your system, you can change the default locking mechanism that's used by setting the transaction isolation level, which is going to be talked about next. So, when you've got read uncommitted, that allows dirty reads, lost updates, non-repeatable reads, and phantom reads. If you've got read committed, now you can't have dirty reads, but you can still have lost updates, non-repeatable reads, or phantom reads. If you've got repeatable read, that prevents everything except phantom reads. And if you use serializable, that prevents everything. Now, there's a much more in-depth explanation on pages 410 and 411 in the text. All right, a little bit more right there. The last thing that's discussed here is deadlocking. So imagine, let's think of we'll think of a computer example. Okay, all right. So let's say that I'm working in a very big company, and I need, as an example, I need to make some changes to a particular database, okay? And so I go in there and I'm able to open up a table, and I'm able to work on a record, the one that I want to change, but I also have to open up another table and change another record at the same time. So I'm person A. I need to open up two tables and change two records. Okay? Then it comes in person B. They need to open up two tables. One is the same as my second table, and one is a different table. All right? And what happens is I've opened up the first table, so I've got what I need and I've locked it. They've opened up the second table that they need, all right, and they've locked it. And let's say we need the same stuff. So we both need the same two tables, and we both need to update the same two records. So I've got table A record 1, and I've got that locked. They've got table B record 1, and that's locked. They won't give up what they have. I won't give up what I have. We're in a deadlock type of situation. And unless one of us backs up and agrees, that we are going to give up our resource so the other person can do whatever it is they want to do, we're in a deadlock situation. All right, now, was that a great explanation? By all means, no. So again, I'm going to quickly jump back over to here, and I'm going to come into here and I'm going to type in deadlock in the reference manual. When in doubt, go to the manual. How to cope with deadlocks. All right? Much more information than I've just given you. They mention deadlocks are a classic problem, but are not dangerous unless they're so frequent that you can't run certain transactions at all. Okay? I'm going to leave it right there. That pretty much is it for what I wanted to talk about for Chapter 14. So I'm going to come back next for Chapter 15 and talk about how to create how to create stored procedures and functions.